April 12, 1944, 1847 hours. Willow Run, Michigan. The assembly line stretches into the distance like a river of aluminum and steel, disappearing into industrial haze a half-mile away. Overhead, fluorescent lights blaze against gathering dusk, transforming the factory floor into perpetual daylight. The noise is overwhelming, pneumatic riveters hammering in syncopated rhythm, metal presses stamping wing sections, electric motors whining as overhead cranes swing fuselage segments into position. Somewhere in this mechanical thunder, a B-24 Liberator heavy bomber is taking shape, its 1.5 million individual parts flowing together in a choreographed dance of mass production that would have seemed impossible 3 years earlier. Shift Supervisor Margaret Daniels checks her clipboard, comparing assembly progress against the minute-by-minute schedule posted on every station. Her crew has 63 minutes to complete their section before the next aircraft begins its journey down the line. 63 minutes to install hydraulic systems, electrical harnesses, instrument panels, control linkages, thousands of components that must fit perfectly, function flawlessly, or kill the 10-man crew who will fly this machine into combat over Europe. Ford Motor Company production record. Willow Run Plant, April 1944. 3,000 miles east in a nondescript building outside Lisbon, Portugal, Hauptmann Friedrich Weber studies reconnaissance photographs with growing disbelief. Weber works for the Abwehr, German military intelligence, tasked with assessing Allied industrial capacity. The photographs, taken by agents who risked execution to operate cameras near American defense plants, show the Willow Run facility from multiple angles. Weber has training in industrial engineering. He understands factory layouts, production flows, workforce requirements. He counts the building's dimensions, 3 million square feet under one roof, the largest manufacturing space ever constructed. He estimates production capacity using standard German calculations for aircraft assembly. His numbers suggest the Americans might produce one B-24 bomber every 8 to 10 days from this facility, perhaps more if they run 3 shifts and accept quality compromises. The estimate seems generous given the Liberator's complexity: 4 engines, twin-tail configuration, retractable ball turret, hydraulic systems, oxygen equipment, armor plating, defensive armor. Each bomber represents months of skilled labor under normal manufacturing processes. Abwehr Intelligence Report 447B, estimated production reconstruction, Bundesarchiv. What Weber does not know, what German intelligence cannot quite believe even when informants report it, is that Ford's Willow Run plant is producing one complete B-24 Liberator every 63 minutes. Not every day, not every 8 hours, every single hour. The Americans have transformed aircraft manufacturing from craftsman assembly to automotive mass production, applying Henry Ford's revolutionary assembly line principles to the most complex machine of the war. The implications are staggering and for Germany potentially catastrophic. Weber writes careful reports describing Allied production capacity as substantial and concerning. His superiors in Berlin file these reports alongside others warning about American industrial mobilization. But numbers on paper cannot convey the reality of what Ford has accomplished. To truly understand requires standing on that factory floor, watching aluminum sheets become bombers with mechanical inevitability, witnessing industrial capacity operating at a scale that defies human comprehension. U.S. Strategic Bombing Survey, Aircraft Division Report, 1946. The story begins 2 years earlier, in the desperate spring of 1942. Germany and Japan control vast territories. American forces are retreating across the Pacific. German submarines are strangling Atlantic supply lines. The Soviet Union is bleeding under Wehrmacht assault. Britain stands alone in Western Europe, sustained only by American aid that arrives in quantities insufficient to reverse Axis momentum. President Franklin Roosevelt, understanding that wars are won by production as much as courage, demands manufacturing miracles from American industry. His stated goal is 60,000 aircraft per year, a number that seems wildly optimistic to military planners accustomed to pre-war production rates of several hundred annually. Henry Ford, 78 years old, and representing the titan of American automotive manufacturing, approaches the challenge with characteristic boldness. If Ford can build automobiles at unprecedented scale and efficiency, why not bombers? The principle, he argues, is identical. Break complex assemblies into simple, repeatable tasks, organize workflow for continuous production, and apply mechanical precision to every operation. Edsel Ford Memorandum to War Production Board, March 1942. The U.S. Army Air Forces initially resist. Aircraft manufacturing, military procurement officers argue, requires skilled craftsmen, sheet metal workers who can hand-form compound curves, mechanics who understand complex systems, inspectors trained to recognize structural flaws. The services have contracted with established aircraft manufacturers, Boeing, Consolidated, Douglas, companies with decades of aviation experience. Ford Motor Company builds cars and trucks, not flying machines. The skepticism is understandable, but fails to account for Ford's extraordinary organizational capabilities. The company that revolutionized automobile manufacturing by reducing Model T assembly from 12 hours to 93 minutes possesses institutional knowledge about mass production that no aircraft manufacturer can match. When Ford proposes building B-24 Liberators, Consolidated Aircraft's heavy bomber design, at a dedicated facility designed specifically for mass production, the Army reluctantly agrees. The alternative is continuing craft production methods that cannot possibly generate aircraft in numbers needed to win a global war. Army Air Forces Statistical Digest, World War II, 1945. Consolidated Aircraft's San Diego plant builds B-24s using traditional methods, skilled workers fabricating components at individual stations, gradually assembling complete aircraft through sequential operations. The process requires extensive floor space, large workforce, and considerable time. Consolidated produces approximately 1 bomber per day from their main facility, a respectable rate given the aircraft's complexity. Ford looks at the Liberator's blueprints and sees not an impossibly complex machine, but a collection of parts that can be manufactured separately and assembled systematically. Charles Sorensen, Ford's production genius and architect of the assembly line system, visits the San Diego plant to study Liberator construction. He watches craftsmen hand-forming aluminum skin panels, fitting them to airframes by trial and error, making constant adjustments to achieve proper fit. The process works but depends entirely on worker skill and cannot be accelerated without proportionally expanding the workforce. Sorensen envisioned something different. Precision dies that stamp out identical parts, jigs and fixtures that ensure perfect alignment, mechanized assembly that moves work to stationary workers rather than moving workers around stationary work. Charles Sorensen, My 40 Years with Ford, 1956. The Willow Run plant rises from Michigan farmland with stunning speed. Construction begins in April 1941, months before Pearl Harbor, as Roosevelt pushes defense production under Lend-Lease authority. The building's dimensions reflect the ambition driving its creation, nearly a mile long, a quarter-mile wide, encompassing 3 million square feet of production space under a single roof. It is the largest room in the world, large enough that weather reportedly forms inside the structure on humid days. Architect Albert Kahn designs the facility specifically for bomber assembly, incorporating innovations from Ford's automotive plants while accommodating an aircraft's unique requirements. The main assembly line runs the building's full length, with feeder lines delivering subassemblies, wings, tail sections, engine nacelles, fuselage segments at precisely timed intervals. Over 40,000 workers will eventually staff 3 shifts, working around the clock to maintain continuous production. The scale is unprecedented, the coordination required nearly incomprehensible, the technical challenges seemingly insurmountable. Albert Kahn Associates, Willow Run Technical Drawings, University of Michigan Archives. Initial production reveals the gap between automotive and aircraft manufacturing. Ford's first B-24s emerged from Willow Run with quality issues, misaligned parts, hydraulic leaks, electrical problems. Army inspectors reject aircraft that don't meet specifications. Workers trained to install carburetors and transmissions struggle with oxygen systems and turbochargers. The learning curve is steep and frustrating. Critics, particularly within established aircraft companies who resent Ford's intrusion into their industry, whisper that automobile manufacturers cannot build aircraft, that mass production inevitably sacrifices quality for quantity. For months, Willow Run operates far below projected capacity, producing bombers slowly while engineers redesign tooling and retrain workers. Henry Ford's promise of 1 bomber per hour seems like typical American overconfidence, impressive sounding, but divorced from manufacturing reality. German intelligence, monitoring reports of Willow Run's troubled startup, notes the difficulties with satisfaction. The Americans, it appears, have overreached. Government Accountability Office, Willow Run Production Analysis, April 1943. But something is happening inside that vast Michigan factory, something the critics and foreign observers cannot yet see. Ford engineers are systematically solving every problem, redesigning every process, refining every operation. The company that spent decades perfecting automotive assembly applies that accumulated knowledge to bomber production with relentless determination. Slowly, then suddenly, production accelerates. By late 1943, Willow Run is producing 1 B-24 every 4 hours. By early 1944, 1 every 2 hours. By spring 1944, 1 every 63 minutes. The transformation from troubled startup to industrial juggernaut happens in 18 months of continuous improvement. And the world is about to witness what American mass production can accomplish when fully mobilized for war. The secret to Willow Run's achievement lies not in any single innovation, but in the systematic application of mass production principles to aircraft manufacturing. Henry Ford's fundamental insight, developed over decades of automotive production, is that complex products can be assembled from simple, standardized components if the manufacturing process is properly organized. The key is breaking assembly into sequential operations, with each worker performing one specific task repeatedly rather than multiple workers collaborating on entire subassemblies. This approach seems counterintuitive for aircraft manufacturing, which traditionally relies on skilled craftsmen who understand entire systems. But Ford proves that properly trained workers performing narrow, specialized tasks can achieve both higher productivity and better consistency than craftsmen working with broader responsibilities. Ford Motor Company, Willow Run, mass production methods applied to heavy bomber manufacturing, 1944. The B-24 Liberator contains approximately 1.5 million individual parts when one counts every rivet, bolt, washer, wire, and component. The aircraft weighs 36,500 pounds empty, stretches 67 feet long with a 110-foot wingspan, and stands 18 feet high. 4 Pratt & Whitney R1830 twin Wasp radial engines, each producing 1,200 horsepower, power the bomber to a maximum speed of 290 miles per hour and a service ceiling of 28,000 feet. The Liberator carries a 10-man crew and up to 8,000 pounds of bombs over ranges exceeding 2,000 miles. It mounts 10 .50 caliber machine guns in defensive positions, nose, tail, dorsal, ventral, and waist, making it a flying fortress bristling with firepower. The aircraft's distinctive twin-tail configuration provides stability, while the high-mounted Davis wing design offers excellent lift characteristics. Every one of these features requires precise manufacturing and careful assembly. Ford's achievement is organizing production so that 1.5 million parts flow together into operational aircraft with assembly line efficiency, technical order 120 EG1, B-24 Liberator Handbook, 1944. Willow Run's production process begins with raw aluminum sheets delivered by rail from Reynolds and Alcoa smelters. The aluminum moves to stamping operations where massive hydraulic presses, some weighing over 200 tons, form flat sheets into compound curves matching precise specifications. Engineers at Ford's River Rouge complex design custom dies for every stamped part, ensuring dimensional accuracy that eliminates hand-fitting. Workers trained for specific stamping operations can produce hundreds of identical wing ribs, fuselage frames, or control surfaces per shift. The stamped parts move to sub-assembly areas where they're joined using both rivets and spot welding. Ford pioneered extensive use of spot welding in aircraft construction, a technique borrowed from automotive manufacturing that provides strength equal to riveting with greater speed and consistency. Each subassembly, a wing section, a bomb bay door, a nose cone, undergoes inspection before moving to the main assembly line. Ford Engineering Department, Willow Run Process Documentation, 1943. The main assembly line operates continuously, 24 hours per day, 7 days per week. A skeletal fuselage frame begins the journey at one end of the mile-long building. As it moves down the line, conveyed by overhead trolleys at a steady 3.5 feet per minute, workers at sequential stations add components. First comes basic structural assembly, bulkheads, stringers, floor sections, then fuel tanks, hydraulic lines, electrical harnesses, control cables threading through pulleys, oxygen system plumbing, instrument panel wiring. Each operation is timed and sequenced so that work at one station completes just as the aircraft arrives at the next. Workers receive extensive training on their specific tasks. Some install only hydraulic fittings, others only electrical connections, still others only control linkages. The specialization seems extreme, but it allows rapid training of new workers and maintains consistent quality. A welder from Detroit can learn to rivet wing panels in days rather than the months required to become a journeyman aircraft mechanic. War Manpower Commission, Training Program Analysis, Willow Run Plant, 1944. German engineers, when they finally obtained detailed intelligence about Willow Run's operations through a combination of escaped prisoner reports and technical analysis of captured B-24s, struggle to reconcile what they're learning with their understanding of manufacturing. A Luftwaffe technical intelligence officer reviewing a report describing the 63-minute production cycle annotates the document with skeptical comments. Impossible given component complexity. Likely propaganda exaggeration. Verify through alternate sources, dramatized composite, based on Luftwaffe technical intelligence assessment protocols, Bundesarchiv. The skepticism reflects not just German doubt, but a fundamental difference in manufacturing philosophy. German aircraft production relies on skilled labor and craftsmanship, with companies like Messerschmitt and Focke-Wulf organizing production around teams of experienced workers who fabricate and assemble entire aircraft sections. The approach produces excellent aircraft. The Bf-109 and FW-190 are world-class fighters, but cannot achieve the production volumes Ford generate. Germany's entire aircraft industry produces approximately 40,000 planes in 1944. Willow Run alone produces over 4,000 B-24s that same year, supplementing production from Consolidated's plants in San Diego, Fort Worth, and other locations. U.S. No. Strategic Bombing Survey Aircraft Production Statistics, 1946. The numbers tell a story of industrial capacity that borders on the incomprehensible. At peak production, Willow Run employs 42,000 workers across 3 shifts. The plant consumes 500,000 tons of aluminum annually. Pratt & Whitney delivers 16,000 R1830 engines per year to support B-24 production across all manufacturers. Hamilton Standard produces 64,000 constant-speed propellers. Thousands of subcontractors supply components, landing gear struts from Cleveland, hydraulic pumps from Milwaukee, oxygen regulators from Los Angeles. The coordination required to maintain this supply chain to ensure that 1.5 million parts per aircraft arrive at Willow Run in the correct quantities and precise timing represents a logistics achievement as impressive as the manufacturing process itself. Delays anywhere in the chain halt production, costing not just money but combat capability. Army Transportation Corps prioritizes B-24 component shipments, ensuring rail cars carrying critical parts receive priority routing. The entire American industrial economy aligns to support bomber production. War Production Board, Transportation Priority System Documentation, 1944. June 6, 1944. D-Day, Allied forces storm Normandy beaches under cover of the largest air armada ever assembled. Among the thousands of aircraft supporting the invasion, 1729 are B-24 Liberators, flying from bases in England, many of them products of Willow Run's assembly line. The bombers strike German positions inland from the beaches, interdict reinforcements, destroy transportation networks, and generally paralyze enemy response to the invasion. Luftwaffe resistance is minimal, partly because German fighter forces have been decimated by months of attrition, partly because overwhelming Allied air superiority makes daylight operations suicidal for German pilots. The B-24s drop their ordnance and return to England with minimal losses. Crews debrief, aircraft are serviced and rearmed, and they fly again the next day, and the day after, and the day after that. The sustainable tempo of operations reflects not just pilot courage, but industrial depth. Enough aircraft that losses can be replaced, enough fuel that operations can continue indefinitely, enough bombs that targets can be struck repeatedly until destroyed. 8th Air Force Operations Report. June 1944. A captured Luftwaffe pilot, shot down during a rare daylight interception attempt, speaks with American intelligence officers at a prisoner of war camp in England. The interrogator asks about German pilot morale. The pilot, a veteran of 4 years' combat, including service over Russia and the Mediterranean, chooses his words carefully. "We know we are brave. We know our aircraft are good. But every day more of your bombers. Every day the formations are larger. We shoot down 10 and 20 appear. We destroy factories and you build more. Where do they all come from? It is like fighting the ocean. You can kill waves, but the ocean never empties." Dramatized composite, based on prisoner of war interrogation report, 2447, 8th Air Force Intelligence, June 1944. His metaphor captures something essential about American industrial production, its apparent inexhaustibility, the sense that behind every aircraft lost stands a factory ready to build 10 more. Ford's contribution extends beyond B-24s. The company produces over 277,000 Jeeps, 93,000 military trucks, and 57,000 aircraft engines during the war. Willow Run's assembly line techniques influence other aircraft manufacturers, with Boeing and Douglas adopting similar mass production methods for B-17 and C-47 production. The psychological impact on German military leadership is measurable in post-war interrogations. Albert Speer, Reich Minister of Armaments and War Production, acknowledges in his memoirs that Germany could never match Allied production volumes. "We were attempting to fight an industrial war with craft production methods." The outcome was determined before the fighting began. Albert Speer, Inside the Third Reich, 1970. His assessment is both accurate and incomplete. German industry faced resource constraints, labor shortages, and strategic bombing that limited production regardless of methods employed. But the fundamental point stands. American industrial capacity, organized for mass production and supported by vast material resources, created quantitative advantages that overwhelmed German qualitative superiority in many weapons systems. The strategic consequences of Willow Run's production ripple across every theater of war. By late 1944, the U.S. Army Air Forces operate over 6,000 heavy bombers in Europe alone, supported by thousands more fighters, transports, and reconnaissance aircraft. The sheer number of aircraft allows sustained strategic bombing campaigns that gradually destroyed Germany's industrial capacity, transportation networks, and petroleum production. Critics debate strategic bombing's effectiveness and morality, but the material impact is undeniable. German war production peaks in summer 1944 despite years of bombing, but then collapses as fuel shortages ground the Luftwaffe and transportation destruction isolates factories from raw material. The collapse accelerates through fall and winter 1944, contributing to Germany's final defeat as much as ground operation. 24s from Willow Run participate in every major strategic bombing operation, attacks on ball-bearing plants, synthetic fuel facilities, aircraft factories, rail yards, and oil refineries. Each mission requires dozens of bombers. Many aircraft don't return. But losses are replaced within days, sometimes hours, by production flowing from Michigan, California, Texas, and Oklahoma. U.S. Strategic Bombing Survey, Overall Economic Effects Division, September 1945. The Pacific Theater tells a similar story. 24s operating from bases in India, China, and Pacific Islands conduct long-range strikes against Japanese positions, shipping, and industrial targets. The Liberator's extended range makes it invaluable for Pacific operations where distances dwarf European theaters. Bombers from Willow Run's production lines fly missions over Burma, Philippines, Borneo, and Japan itself. When combined with B-29 Superfortresses, an even more advanced bomber entering service in 1944, American strategic bombing gradually strangles Japanese war industry and maritime commerce. Japan's industrial capacity, never matching American levels even before the war, cannot sustain losses or replace destroyed facilities. By mid-1945, American aircraft operate over Japan with near impunity, mining harbors, destroying cities with incendiary raids, and generally demonstrating the consequences of fighting a nation that can produce weapons faster than enemies can destroy them. U.S. Strategic Bombing Survey, Pacific War Reports, 1946. The human dimension of this industrial achievement demands recognition. The 42,000 workers at Willow Run represent a cross-section of American society transformed by war. Women comprise approximately 40% of the workforce, many of them taking manufacturing jobs for the first time, as men enter military service. African Americans migrate from the South seeking employment in defense industries, facing discrimination but finding economic opportunities previously closed to them. The plant becomes a crucible of social change, bringing together people from different backgrounds in common purpose. Shift Supervisor Margaret Daniels, checking assembly progress on that April evening in 1944, represents thousands of women who entered industrial work during the war and forever changed American labor force composition. Her story, and stories of countless other workers whose names appear in no histories, deserve remembrance alongside accounts of generals and politicians, Ford Motor Company personnel records, Willow Run Plant, University of Michigan Labor History Collection. Production line workers face demanding conditions, long shifts, repetitive tasks, constant pressure to maintain quality while meeting production quotas. Injuries are common despite safety protocols. The pace of work allows little margin for error or inattention. Union representatives negotiate with management over working conditions, sometimes threatening slowdowns or strikes if grievances aren't addressed. The War Labor Board mediates disputes, balancing worker rights against production imperative. These tensions between labor and management, between individual welfare and collective necessity, between economic justice and military urgency, define American home front experience as much as rationing or victory gardens. The B-24s rolling off Willow Run's assembly line every 63 minutes represent not just industrial capacity, but social mobilization, the transformation of a civilian economy into a war-winning machine through the efforts of millions of ordinary people doing extraordinary work. War Labor Board. Case files, Willow Run disputes, 1942-1945. Engineers and designers also deserve credit for making mass production possible. The transition from craft assembly to assembly line manufacturing required redesigning thousands of B-24 components for easier fabrication and installation. Engineers at Ford worked with consolidated aircraft designers to modify specifications without compromising performance. Some changes were minor, relocating a bracket for better access, standardizing fasteners to reduce inventory complexity. Others were substantial, redesigning the wing structure to allow separate assembly and attachment rather than building wings as integral parts of the fuselage. Each modification underwent testing to ensure it didn't degrade aircraft performance or safety. The cumulative effect was an aircraft optimized for mass production while maintaining the combat capability that made the B-24 effective. This collaboration between automotive engineers and aircraft designers created institutional knowledge that would influence post-war aviation industry development. Society of Automotive Engineers, Technical Paper 440,421, Production Engineering, Applied to Aircraft Manufacturing, 1944. Post-war analysis reveals Willow Run's broader influence on manufacturing philosophy. The plant demonstrated that complex products previously requiring craft production could be manufactured using mass production techniques if proper engineering and organization were applied. This lesson extended beyond aircraft to electronics, machinery, and eventually consumer goods. The aerospace industry, emerging in the 1950s and 1960s as jet aircraft and missiles, replaced propeller-driven planes, adopted assembly line methods pioneered at Willow Run. Boeing's 747 production, beginning in the late 1960s, used techniques directly descended from B-24 assembly line practices. Modern aircraft manufacturing, while incorporating automation and computer-aided design, still relies on fundamental principles Ford applied: breaking complex assemblies into manageable tasks, organizing workflow for efficiency, and maintaining quality through systematic inspection. The legacy is visible every time a commercial airliner rolls out of a factory. It's millions of parts assembled through processes that trace their lineage to a Michigan bomber plant. Boeing commercial airplanes, 747 production system documentation, 1968. The Cold War military-industrial complex, so named by President Eisenhower in his 1961 farewell address, has roots in World War II mobilization. The sustained production capacity demonstrated by facilities like Willow Run convinced American military planners that maintaining large-scale defense industries during peacetime was strategically necessary. The concept of surge capacity, the ability to rapidly expand production during crisis, became fundamental to defense planning. During the Korean War, when B-29 production resumed to replace aircraft lost in combat, manufacturers applied lessons learned during World War II to achieve production rates that, while not matching wartime peaks, far exceeded pre-war levels. Similar patterns appeared during Vietnam, the Reagan buildup of the 1980s, and Gulf War preparations. Each instance reflected institutional knowledge about mass production that originated in factories like Willow Run, Rand Corporation, Defense Industrial Base Studies, various dates, 1950-1990. The psychological dimension of industrial capacity deserves examination. German military leadership, confronting evidence of American production volumes, faced not just material disadvantage, but cognitive dissonance. Officers trained to believe in German technical and organizational superiority struggled to accept that quantitative advantages could overwhelm qualitative edges. Some retreated into denial, dismissing intelligence reports as exaggerated or fabricated. Others recognized the truth but felt powerless to counter it. Germany's resource base and industrial capacity could not match America's regardless of efficiency or organization. This psychological burden, knowing defeat was mathematically inevitable, contributed to deteriorating German morale as the war progressed. Soldiers could convince themselves they were braver, better trained, more ideologically committed than their enemy. They could not convince themselves they could win when outnumbered 10-1 in aircraft, tanks, and artillery. U.S. Strategic Bombing Survey, Morale Division, German Military Leadership Assessment, August 1945. American aircrews flying B-24s built at Willow Run rarely thought about factory workers or assembly lines. They focused on immediate concerns: flak over targets, fighter attacks, mechanical failures, navigation challenges. But the psychological security of knowing that lost aircraft would be replaced that the war effort possessed depth and sustainability, affected morale in subtle ways. Crews could accept missions with dangerous loss rates because they understood the larger industrial machine supporting. A bomber shot down over Germany represented tragedy for its crew but not strategic setback for the war effort. Another B-24 was already rolling off the Willow Run line to replace it. This calculus, cold but accurate, defined American strategic bombing doctrine. The willingness to accept losses, to grind down enemy defenses through sustained operations, regardless of cost, reflected confidence in industrial backing that Germany could never match. 8th Air Force Operational Research Section, Crew Morale and Mission Effectiveness Study, December 1944. One final perspective comes from a Ford engineer's diary entry written in May 1945 as victory in Europe became certain. We built 8,685 B-24s here. Each one carried 10 men and 8,000 pounds of bombs. Simple mathematics. 86,850 men flew our aircraft into combat. Some never came home. The bombers did their job, but so did we. We kept building, kept improving, kept the line moving. That was our contribution. Not glory, not medals, just steady work, day after day, shift after shift. Maybe that's what winning looks like. Not dramatic gestures, but sustained effort, industrial capacity transformed into combat power through the labor of thousands of ordinary people doing their jobs well. Composite dramatized entry. Based on worker accounts from Ford Motor Company Oral History Project, 1984-1987. The lesson transcends World War II. Modern warfare remains fundamentally about industrial capacity, about the ability to produce, sustain, and replace military forces faster than enemies can destroy them. Technologies change. Precision weapons replace mass bombing. Stealth aircraft replace formations of heavy bombers. Information networks replace radio communications. But underlying principles endure. The nation that can mobilize industrial resources most effectively, that can organize production most efficiently, that can sustain military operations through superior logistics and manufacturing, possesses decisive advantages. Willow Run demonstrated these principles at a scale that shocked contemporaries and influences military thinking 80 years later. Every 63 minutes, another B-24. Every hour, another contribution to victory. Every shift, another reminder that wars are won not just by soldiers on battlefields, but by workers on factory floors, by engineers at drawing boards, by managers organizing complex operations, by entire societies mobilizing for sustained effort. That was Willow Run's gift to history. Proof that industrial democracy, properly organized and fully committed, could outproduce and ultimately defeat any opponent. The bombers are long gone, scrapped for aluminum after the war, or preserved in museums. But the lesson remains inscribed in production records and victory reports. Never underestimate what free people, working together toward common purpose, can accomplish when the stakes demand their best efforts.